A spherical snowball is melting. Its radius decreases at a rate of 2 centimeters per minute from an initial value of 70 centimeters. How fast is the volume decreasing half an hour later?
So in order to solve the problem, the first thing we do is to draw a diagram. It helps us to visualize the problem and solve the problem. So this is the snowball and this is the radius. And then we are going to identify the values. So from the question we have initial radius equals 70 cm, and then the rate of change of radius 2 cm per minute.
So now we're going to introduce some equations into our problem. So first we're going to use the equation for the radius, which is 70 minus 2t, since we start with a 70 centimeter radius and we decrease by 2 centimeters each minute. And we're also going to use the volume for a sphere equation. So now what we need to do is combine these two equations. So this is a source of confusion in some related rate problems, since we have two different equations and we need to find a way to combine them so that we can find the rate of change of one variable in terms of one other variable. So in this case, we make it a little bit easier because we can easily substitute the radius value into r here in the volume equation. And now we have our combined equation, and this way we can find the rate of change of the volume in terms of time.
So now that we've established a formula for the volume of the snowball, the question asks how fast is the volume decreasing. So we need to look at the rate of change of the volume. And we know that that means that we have to take the derivative of the function. And here we're going to use the chain rule. And if we simplify that, we get... And of course, we don't forget the units, centimeters cubed per minute. Now, the question is even more specific, asking how fast the volume is decreasing half an hour later. So now we have to plug in a value into t. And since t is in minutes, half an hour is equal to 30 minutes. So therefore, this is the rate at which the volume is changing half an hour later.